Pre-AP, Precalculus. Free response question number 10. We're in chapter 2 right now. Cannot use a calculator for this. The graph of the function h of x is pictured to the right. That is this black curve. Another function, g of x, is defined with this equation. So we got h here, we got g here. Identify the intervals along the x-axis where h of x is bigger than 0. Explain your reasoning. I'm going to explain my reasoning first. If h of x is bigger than 0, then the graph of h of x is above the x-axis. So when is it above the x-axis? Just to the right of -5, just before you get to -1, just after -1, to get just before 2, and then right after 4 to 5 non-inclusive. So that's a 1, 2, 3 intervals. -5 to -1, -1 to 2, and then from 4 to 5, all non-inclusive. Part B, if f of x, this is a third function. So we got h, we got g, and now we got f. If f of x is the absolute value of the sum of 2x and 1 minus 4, then for what values does f of x equal g of h of 3? Show your work. So we're going to get, I should have mentioned the last one, there's 1 point for each of those answers. This one's a 2-pointer. You get 1 point for identifying what g of -4 is. Show your work, you're going to get -1 plus 2. You are plugging, well, let me go back a little bit. First of all, what's h of 3? Go 3 here, if you go to 3, you have to go down to -4. So h of 3 is -4. Then to figure out what g is, you take -4 and you put it in here for x, and you're going to end up with 1. So you get 1 point for this. Then if you set that equal to this, because when does f of x equal that? You get 1 point for setting those equal to each other, and then solving this. The weirdest part, I guess, would be once you get the absolute value by itself, you say the absolute value, take those off and say it's equal to plus or minus 5. Subtract 1 from both sides, divided by 2. -1 minus 5, that's a -6 over 2. -1 plus 5, that's a +4 divided by 2. We get those two answers. 1 point figuring out what g of h of 3 is, and then 1 point for setting that equal to f of x, and then solving for x. C. On the same grid as h of x, graph g of x. Let's do that first. So how did we graph this? This has the vertex of -5, +2. That's right here. This negative is a vertical reflection. So instead of going right and up, we're going to go right and down. So if we go to the right 1, square root of 1 is 1. If we go to the right 4, square root of 4 is 2. If we go to the right 9, square root of 9 is 3. We're going down once again because of this negative. Gives us this graph. Starting point goes to the right forever. On the same grid, graph g of x, then determine for how many values it can be said that h of x equals g of x. Give a reason for your answer. I always give my reason first. How am I going to know when these are equal? That's what I ask myself. Well, h of x equals g of x when the graphs of h of x and g of x intersect. And then how many times do they intersect? 1, 2, 3, 4 times. H of x and g of x equals g of x for 4 values of x. This is all 1 point for the reason and the number of times. So far we got 1, 2, 3, 4, 5. Actually, that's 1 point. 1 point was graphing it. So that was worth 2 points. 1 for explanation and how many times, and 1 for the graph. Part D, find an equation for G inverse if it exists. If G inverse does not exist, give a reason why. Well, this is going to exist. This is not part of the answer, but I'm just explaining. Because this is if you look at the graph of G of x, passes the horizontal line test. Or you could say it's a constantly decreasing function. There's 2 reasons why. Notice the restrictions on the domain and range for this. It's not all real numbers for the domain or the range. So our answer for this is going to be a little bit restricted. So here's g of x. Its range goes from -infinity to 2. Its domain goes from -infinity to, I'm sorry, I said that wrong. The range of g of x is what I said. The domain of G inverse would be that same range, because a function in its inverse, you interchange x and y. So we're concerned about the domain of G of x, G inverse of x. That's why we said what the range of G of x was. Now this part here, you don't get any points for writing this down, but I'm just explaining where I'm getting this stuff from. So this is worth 3 points. You get 1 point for finding the equation of G inverse. And you're going to get, well, I'll get to the points in a second. If it does not exist, give a reason why. It does exist, so we don't have to do that. You get 1 point for knowing to find the inverse, you interchange x and y. You get 1 point for successfully executing getting y by itself. And a common mistake folks make in here is you really want to get the square root by itself before you square both sides, which is what I did. So when you write the inverse function, G inverse, you have to give the domain restriction. The domain restriction is that x has to be less than or equal to 2. If you don't do that, then you're not going to get this last point. That concludes free response question number 10.